What are some of the fundamental principles of data visualization? Data visualization is a strange discipline. It isn't like other math or stats discipline where you have theorems and you have things that have been proven. We have a set of best practices and some experience to suggest that these are indeed best practices, but there's a lot of varying, diverging ideas as to how to do these things in the best manner, and not everybody agrees. We don't have a consensus on what these fundamental principles are. And the first author that I am quoting here is Edward Tufke, who's known as the grandfather of data visualization. So he's produced 4 books that have been excessively influential over the last 20 years. He's not the first person to have talked about data visualization, of course, but he might be the reason why it's as popular as it is. And his approach here, or his thoughts on the matter, is that the way we reason and communicate our thoughts is intertwined with how we live our lives in a universe which is both causal, at least to some extent causal, and dynamic, but more importantly, multivariate, which means that it's never just one thing in isolation that we're interested in looking at. We are looking at multiple things that interact with one another simultaneously. And if we want to try to understand a little corner of the universe, we need to look at many things within that little corner. So if you're looking, for instance, at the economic disparity in the country, it's not enough to just look at salaries. You have to take into account gender variables, education variables, ethnic variables, a bunch of things that might not seem directly linked with salaries, but that in practice are, due to a variety of societal reasons. His big take, though, is that as producers of visual displays, you should put in there what you need to see as a consumer of a visual display, and vice versa, that the consumer should be seeking exactly what it is that the producers are providing. He's not giving us technical details about when to use a bubble chart and when to use a bar chart and when to use a map. He's saying that whatever chart you produce, whatever dashboard you produce, should allow the user to make meaningful comparisons. It should show as much as possible the underlying structure in the data, and if you can, and this is really difficult to do so, causality, causal networks. What it is that causes a specific chunk of data to be the way it is, if you can, highlight that link. It's hard because causality is very difficult to prove. Does tobacco cause cancer? We have no proof that tobacco causes cancer. At least we don't have a data proof that tobacco causes cancer. What we have is a lot of data that suggests that there's a very strong correlation between the usage of tobacco and the occurrence of cancer. And we have a lot of evidence to eliminate other possible causes, but we're not able to prove, at least not with data analysis or data visualization, that tobacco causes cancer. It doesn't matter. We know tobacco causes cancer. This is not up for debate. But showing a causality relationship is very difficult with data, and so very difficult to visualize. We can hit. The Tufte has a sort of variation on this. Causality is not causation. Correlation is not causality, but it's a big hint. Okay? We can't dismiss correlations just because they don't equate to causality. And knowing what variables are correlated together actually helps the experts down the road formulate hypotheses that they can test with other means. Multivariate links should be part of your displays. If all you ever do is show what we call univariate visualization, visualizations that only ever talk about one variable and no interactions between variables, you're probably wasting your time and my time as a consumer. Your chart should include integrated and relevant data. That's harder than it seems. documentation should be honest. Now, again, it's easy for me as an outsider, a consultant, to come in and sort of insist on documentation. As a cog in the visualization machine, you might not have as much of a say in what documentation gets put out there, but come up with decent documentation. Let people who want to know more about the visualization have the chance to do so. Tell them where to get the data. Tell them how the data has been cleaned. More importantly, perhaps the primary focus should be on content. That would seem to disqualify infographics, where the design there is quite important. I still think the design is important, the design element, but the focus should be on the content. Here's an example of what we mean by non-integrated data. I suspect some of you might have seen this chart before. It's becoming a pretty famous chart. Without integrated content here, it might be hard for you to know what this chart is about. It doesn't have a title. You just see a bunch of bubbles. We have some information on the vertical axis about life expectancy. These look like they could be human years, so age. And on the right, I have income per person, GDP per capita in dollars per year, adjusted for inflation and prices. All right, as a non-economist, I don't fully know what this sentence means, but presumably as accountants, you look at this and you're like, yeah, okay, that makes total sense. And I'm looking at the scale and I see numbers going from about 500 to about 128,000. So then what do you think we're looking at here? What are the design elements? If we don't know what these bubbles represent, if the data is not integrated, if we don't have context, it's hard to make sense of this. If you want to live longer, is it better to be wealthy or not wealthy? This is actually part of a very famous map called the Health and Wealth of Nations. So here the bubbles actually represent countries. The color represents continental membership, and the size of the bubble tells you how populous the country is. So when we're seeing these big bubbles, before what we were really looking at were India and China. Okay, so it's starting to make a little bit more sense. We're seeing a number of countries, the ones we would expect here, and we're seeing a number of countries at the tails. Income per person is lower here, life expectancy is lower here, income per person is higher here, life expectancy is higher. Now understand, when we're talking about income per person, we're talking about an average. When we're talking about life expectancy, we're talking about an average as well. So it's not true that all Japanese nationals live to be 85 years old and that they all have what seems to be about 30,000 income per person, right? Let's look at this chart through the eyes of the 6 things that Tufte suggests we look at. The first one is, does it allow us to make meaningful comparisons between various observations? Here, by comparison, I mean, we can look at the size of countries. We can see at a glance which countries are populous and which countries are not populous. India and China are big. The United States, Japan are big. Canada, not so big. Syria, not so big. Of course, all of this was in 2012. The numbers might have changed since then. So we can make meaningful comparisons, not just in terms of the size, but in terms of the placement of the bubbles. The further to the right a bubble is, the wealthier the country is supposed to be. The higher up a bubble is, the healthier the country is supposed to be. So by looking at this, we would say, well, Japan seems to be a healthier country than the United States, but the United States seems to be a wealthier country. Or if you want to look, say, at Madagascar here, as a country, it's below the life expectancy of the world, not by much, just a few years. Do you even agree that using life expectancy is a good proxy for health? Do you agree that using income per person is a good proxy for wealth? I'm not sure that this is a perfect correlation. In terms of finding underlying structure and multivariate link, if you take off your glasses and you squint, take a few steps back, it certainly seems as though these countries line up. That's at least somewhat interesting to see, to think of. You might also look at groups of bubbles. There's, roughly speaking, three groups of bubbles. I mean, this is a completely arbitrary choice to separate the countries in chunks like they were here, but it sort of matches some understanding that we have of the socio-political history of the planet. I haven't really highlighted the idea of causality. Do we think that's the case? Is there a relationship between wealth and health? Is it the case that wealthier countries tend to have longer living citizens? It certainly seems to be this based on this chart, and what we don't know is whether there's a causal relationship. Could it be the fact that when people live longer for whatever reason, that also causes them to be wealthier? It seems unlikely. Like, it doesn't match with my understanding of the reality. But what do I know about it? Perhaps there is a causal relationship and it goes the other way around. Perhaps there's a causal relationship, some other factor. It could be something as simple as political system that leads to both higher wealth and higher health. Causal relationships are hard to highlight. I'm stretching a little bit when I identify Vietnam and Palestine and Nicaragua here as odd countries, but I think you'll agree with me that there's a group of 5 countries here that seem to buck the trend to some reason. They're not where we would expect them to be if the linear trend we saw here was a good trend. We would expect South Africa to be closer to China in terms of life expectancy. So we would expect the wealth of South Africa to be closer to Zimbabwe based on life expectancy. So what is going on here? Can we use any of the data to explain why these countries look like outliers? No, we don't have data evidence that help us draw these conclusions. This is probably a manifestation of a pronounced income disparity. I'm going to take South Africa here and split it into two countries, the Afrikaner descendant population and the Black South African population. We would probably see something more like this. Yeah. The fact that the bubble is right to the right here tells us that, well, the Afrikaner population is probably much wealthier than the Black South African population. But the life expectancy isn't drawn that much because the life expectancy isn't weighted by anything. Like, if let's say it's an 80-20 split in terms of Afrikaner and South African, well, the life expectancy of the Black South Africans would drive the life expectancy of the country as a whole. That, again, 80-20 split in terms of population, but let's say the split in terms of wealth is actually reversed, 20-80, then you would see that the wealth of the Afrikaners would really draw the country to the right. Now, we don't know for a fact that apartheid and years is responsible for that data point being where it is, but it seems like a pretty good guess. Conclusion can only be drawn from contextual understanding of apartheid and a bunch of other things. We can't use the data to prove this. I mean, if we were to take Canada, for instance, and split it into French, English, and indigenous populations, we would probably see something similar as well. So the choice to represent this chart using national data, country data, it's an arbitrary choice, and it tells a specific story, a story in which we can probably feel like patting ourselves on the back. Look how well we're doing here. Everybody is happy. Everybody's wealthy. It's a great story. That only tells part of the story. Context is not the same as the chart. Like, we understand this chart, we appreciate this chart because we have an understanding of the world at large, but of course you show this to aliens and it'll mean absolutely nothing. We have to be able to differentiate what the chart is actually showing and what it triggers in our understanding of a situation. It has, on top of that, although this is not something I'm seeing people do very often, it has an amazing documentation. Not only does it have a nice legend, but if you take the time to follow the link, you will find about a 30-page document that tells you how they collected the data. Do you believe that the Canadian life expectancy is about 82 and that income per person is about 35,000? Does that strike you as likely? But do you know what's happening in North Korea? I tell you that the GDP is here and the life expectancy is here. You believe it? How do you combine so many different observations if you don't have a central organization to collect and measure the data? So the documentation is a masterclass and data collection, data cleaning. I know nobody's going to read this for real, but if ever you want to know what it should be like, this is what a good documentation looks like. How do you present analysis results? Look, your graphics, they should be clear and engaging. That graphic here, it's clear and engaging. Well, according to my standard of clearness and engagement, I think most people react to this. It speaks to them about something that they understand at some level. But most people, really, like if I showed this to my 17-year-old, is this something that would engage her? Not every pretty picture will tell a story, but if it's impossible to tell a story with pretty pictures, perhaps you need to rethink your story. There's going to be tons of new graphical representation techniques. It's too early right now to tell which representation techniques will stand the test of time, which ones will still be used 50 years from now. What this means is that you shouldn't be too worried about trying new techniques, new approaches, new ways to show data if it helps convey the message. But how do you know if it helps convey the message? You need feedback from your audience. Do you understand what I'm trying to say when I'm using these charts? In terms of what design elements go into the charts, in the Gapminder chart, we had 4 design elements. We had the horizontal position, which gave us the wealth measurement. We had the vertical position, the life expectancy. We had the size of the bubble, which gave us the population. And we had the color of the bubble, which gave us continental membership. So we were able to use 4 design elements to map to 4 variables. So on a 2-dimensional surface, a 4-dimensional data set. And we were able to see some relationship between all of these elements. There's a 5th element we could have used here, which is the passage of time. This was a chart for 2012. What happens if we try to find the same chart for 1918, 1919, 1920, 1921, and so forth? So we can build multiple charts and then stitch them together into a movie. And then we will be able to see the passage of time. All right, so the place where you want to go to get this information is Gapminder tools. So I'm going to play the movie here from the 1800 onwards. So let's just see what it looks like. And you're seeing the passage of time. And you're seeing one of the story elements that you cannot see from the chart alone is the inexorable momentum that China and India have. Get this again. There's a fair amount of movement. If you know your Chinese history, you can probably guess what just happened there. And then the momentum. If you ask me to predict what's going to happen in 2030, say assuming that we don't manage to blow ourselves up in the meantime, it looks as though India and China are just really moving this way. There's a few items I want you to keep in mind. If you go back to 1800, you're seeing a fair number of countries here. And of course, all of them are in the bottom left corner. The thing is, the life expectancy 200 years ago and now, it's comparable. And you'll say, but money has changed. Money is not the same, except the money here has been inflation adjusted. So in essence, this is truly comparable to $736 per capita now. So 200 years ago, it looks as though most countries would have been in the bottom left. As time passes, we are seeing a movement from the bottom left to the top right.
I don't want to get people excited, but what Pat is doing here in terms of putting a time axis on a bubble chart, you can actually do in Power BI. So hopefully by the end of the week, we may not be able to do it with this data set, but I'll show you guys how to animate a bubble chart like this.
Look at this movement here. I'm moving a few years, and you're seeing this bubble drop a fair amount. Does it make sense that in 1 year, the life expectancy went from being around 25 to 20, then back to 25? What's more likely is that there might be some uncertainty in the data. Let's keep on moving it a little bit. Again, we're seeing some movement. Oh, we saw a country. You see this country here, Ethiopia, went completely off the chart.
Yeah.
Same sort of idea, right? Is this a data error, or did everybody die in the country? We know that that can't have been the case. There's a few other things I want you to keep in mind. Like, what about countries that ceased existing? Like, if I follow the Czech Republic in 1800, It was part of Austria-Hungary for a while. So when we get these numbers here, life expectancy stays exactly constant over time. Something isn't right with this. That's a data issue for sure. How do they recognize the breakup of Austria-Hungary? How do they recognize the breakup of Czechoslovakia? So if you look at the documentation, you'll get some sense of that. It's a good visualization because it allows you to ask questions about its flaws, about the ways in which it doesn't do what it should be doing. It is not a bad thing if your audience is worrying or wondering if there's some data issue. You've made the visualization engaging enough that try to rule out any potential data problem. You need to use design elements, you need to pick colors, you need to pick marker size, shapes. You need to make decisions about the design that's going to help you convey the message. As it happens, the way our eyes deal with various shapes and various colors and various directions, the choices you make are not completely random. Some choices are better suited to represent specific types of information than others. We have some suggestions, some ideas as to what are best choices, but here we don't have science for that. It's really based on opinions for the most part. If you add design elements, you add understanding of the data. That's important because the displays you choose, it's not just about picking a random visualization method. The result depends on the story you're trying to tell, but also on the structure of the data and the types of questions you want to ask the data. Look at this data set here, the NASA CM1 data set, and it's basically information about the code that is involved in various components of the NASA spaceships. In 2 dimensions, you can always use 2 variables to be represented by position. So if you have 2 numerical variables, or 2 variables that can be ordered, even if they're not numerical, then you can have 2 dimensions. So that's good. There's other factors that you can depict your data set with. You can use the size of your marker, the color of your marker. You can add a value next to the marker. You can have texture. Think back to the old Mac days, fill with vertical lines or horizontal lines or diagonal lines. There's a line orientation. There's the shape of your marker. There's motion, as I've shown you. So you can, in theory, you could add a gift 2 variables for position, 3, 4, 5, 6, 7, 8, 9. You could represent 9 dimensions on a flat screen. But our brains aren't that good at putting together a coherent picture if you have too many variables. So in practice, 4 or 5 variables is about the extent of what you can really demand out of people. So the Gapminder chart for me is a good example. Wealth, health, population size, continental membership, and the passage of time. Because we have the tools now to map the passage of time. But that's about the extent of this. If you add more, I mean, you can represent other variables. You do shape for languages, that could have happened, or families of languages. But it's starting to be a lot of information. Better for you to produce multiple charts about the same data set using various dimensions and variables, various design elements, than to try to put too many elements on the same chart. Here's the same chart as the one we had before, but now I'm actually using the shape to map the code was defective or not defective, the size to tell you how big the code was in each category, and the color to define something which is called the intelligence per language. And so now, I mean, look, this chart doesn't really give us that much information unless we know a lot about the context, but it's probably easier to parse, easier to understand than the black and white chart on this slide. For instance, I'm getting the sense that the defective pieces, the squares, tended to have more lines of code. I'm seeing bigger squares on average than I'm seeing circles. Perhaps that's not completely surprising that if you have more lines of code, you're more likely to have a defective bit. And the time spent per line of code as well, we're not seeing defective pieces here. They spent a fair amount of time on that, but who knows? The only point I'm trying to make with this chart is that I hope you will agree with me that using design elements actually makes it easier or gives me a better chance to understand the data set. I purposely picked a data set which was not interesting to most people and in which the insight isn't really there. There isn't that much insight to be had, just so you can see that in spite of that, adding design elements, adding plot elements makes it actually easier to work. You've seen data visualizations over the years. You've picked up rules unbeknownst to you. Has anybody ever heard no pie charts? Stephen, I know you're a strong proponent of the no pie chart theory. I'm a little bit less hardcore about pie charts not being used. Sure, perhaps there are times when it could be useful to have a pie chart. You've picked up rules over the years. What are those rules? Do you know what they are? Can you explicitly write them out? Are they hard rules, or are they rules that could be bent somehow? Because the true rule that you have is you need to help convey the message. Anything that allows you to convey the message is good. Anything that hinders you in your ability to convey the message is sort of a bad thing.